There, Rick here. Okay, I wanted to teach a little bit more about the multimeter. I myself have learned things recently. Thank you, John Anderson, for enlightening me on how these things work. Okay, we have as a basic multimeter. This symbol right here is telling us that is DC volts. It has a line with little hashes underneath it, meaning it is DC volts. Then we look right here and we have a wavy line underneath that. That means AC volts. Then we have up here the amp scale and high voltage. Then what we have over here is called the ohms scale. And also on your ohms, it will have a beeper or signal insignia. And I call the ohms the upside down horseshoe. Anyways, let's learn about this. First thing we're going to do, we're going to check ohms. Ohms is important to know that you have a good nano coating. You got to know that it's it doesn't have any continuity running through it. Ohms is resistance, how much electricity will run through it. Now, what John Anderson taught me is that when you're on the ohms scale, and I've turned my dial right to the little symbol, when you're on the ohms scale, it sends out little pulses through the lead to the other lead. And when that pulse is received on the other side, it will tell you how much resistance you have, how much the electricity will not flow. Resistance means continuity. So if you touch the two, you'll see right there that we are at 0.6.5. And you hear the beep. You hear the beep? There it is. Okay. Now, so checking continuity, a piece of copper should be perfect. I mean, it travels with electricity. So when you ohm out a piece of wire, you have the same reading. And I believe that's probably just the coating of the zinc that is on the terminals here, is the resistance that we're measuring. So on a piece of wire, we are there at 0.5 ohms. Now, it doesn't matter how big you get or how far apart you get. So even if I take that piece of copper there, you see we're reading about the same. Through the distance of a cord, you will receive more resistance because of the length of the copper. Here, what we have is a piece of zinc. This is a used piece of zinc. And we still are reading that electricity will flow through this nicely because we have very little resistance. Then, let's check out a piece of nano-coated copper. We check that copper. Nothing. 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 That's why I call it a brick. It's like a rock. Here's a rock. Black basalt. Native of Oregon. It's nothing. It's a rock. Test it right next to each other. It's a rock. Same thing with our nano coating. Oop, I dug through it. There we go. There's our nano coating. I stuck it in too deep. And you can see if we put them right next to each other. See, this is a weak area in the nano coating. This is an old piece of plate. But that's how that works, is you're checking continuity through the plate. This piece is not really a good piece of nano coating. It's kind of scratched up. But it gives you an idea of what nano coating should read like. We are checking continuity through the plate. It's a rock. Okay, just like this. That's what you're measuring. No electricity will flow through it. So here's another thing we use. We use the millivolts. So DC volts, 200 on the millivolt scale. I'll focus in on that. Come back out. Boy, that thing doesn't focus. But see, we're on the 200 millivolt on the DC scale. So then, what I'm going to do is I'm going to drain the voltage. So we are going to take a piece that I have going right now, and you can see this is a fresh piece of nano coating copper. I'm going to touch on one end and on the other end. And you'll see the voltage jumping around. It'll go up, it'll go down, it'll go up, it'll go down. what I do is I count to 10 in a couple different places going across the plate. So then I'll move my electrodes into a different position to a count to 10, and the voltage is up and down, up and down. And then one more time, we'll go across the plate. We're draining the voltage out of that plate. Now, here's another one, so I'll take this one back, and then I have a pain pin that I'm doing here. We'll drain the voltage on that. We'll put the lead on one side and touch to the center pin, gravitational pin, and we're draining the voltage out. You can see how it slowly go down, but it'll jump up and down. But that's how we are draining the voltage to allow the nano layers to build. Now, the way I understand it, and I could understand it or say it incorrectly, but for the nano layers, when you activate it, they grow, and they grow like a sponge, and they're very tall, and they'll grow and grow. Well, once you relieve and drain the pressure, that sponge will collapse and form a good hard layer, allowing another layer to build on top of it as a sponge form. You drain the voltage, it collapses, builds another strong layer. If you don't drain the voltage, you're going to get a puffy, poofy type of nanocoating. You want it solid and hard with its natural robust. And we just touch it from one end to the other, and it drains the voltage. And that is how we use the multimeter. So that's about it. Hey, I hope that helped you guys. Well, I'll be talking to you soon. I have more information to show later on. Take care and peace to y'all.